Thanks for being here. My name is Muhammet. I'm a Python developer at a company called Metadata, which is a wholesaler of hotels and plane tickets. You can follow me on Twitter at @menukaya. So I'm going to talk about SQLAlchemy and how we can use it, how we're going to explore it. SQLAlchemy is a mature, high-performing, and modular Python library that you can use to work with your database. It lets you construct your SQL queries with Python functions. It also supports separation of mapping and classes, which is you can have an ORM and you can map your tables to Python objects. And it also lets you either load or cache the related objects that you retrieve from your queries, and it also lets you run raw SQL statements. SQLAlchemy supports Postgres, MySQL, MS SQL, and SQLite, Sybase, Drizzle, Firebird, and Oracle. And we are going to inspect SQLAlchemy as two parts. One is core and one is ORM. The first one I'm going to talk about is core. SQLAlchemy core consists of 6 objects, which is engine, connection, dialect, metadata, and table and column. Engine is the starting point for your SQLAlchemy application. It is the home base for all of your database, its connections, its tables, and its API. Connection is a wrapper class of your database's Python library. For example, there is CyclePG for Postgres or MySQL Python for MySQL, and connection is a wrapper class above them. All the SQL statements are executed through connection class, and it's not thread safe. Dialect is the class where SQLAlchemy generate queries, execute queries, or handle the results, which may vary from database to database. For example, a select statement could be different in Postgres and it could be different in SQLite. And the dialect class, when you construct your query, generates the query that you want to construct according to that database. Metadata is the class that is binded to an engine or a connection which holds the table and column information. And the table class is the class that you map your tables in the database, which you store in the metadata. And the columns are simply the columns in your table. So when you want to create an engine in SQLAlchemy, all you have to do is to import the create engine function, and then give it a database URI, and then the echo parameter there is just to say that log the output, what SQL query you ran. When you want to create a table with SQLAlchemy, all you have to do is to instantiate a table class, and give it a metadata, and you define your columns in the table as argument, and all you have to do is to call create all on the metadata or create on table object. And this is an example you can see. We are importing create engine from SQLAlchemy. We are instantiating a metadata object, and then in the countries table, we are using the countries string as its first argument, and giving the metadata that we have just instantiated, and then giving the column data as arguments to table class. And as you see, we have different types, such as integer and Unicode text, and all these are Python classes for SQLAlchemy. Those that are in SQLAlchemy. So this usage is not the only parameters that columns have. Columns also have index, nullable, unique, and primary key and other increment arguments, which are Boolean, which takes Boolean values. So this basically says this column should be indexed, or this column is unique, or this column is a primary key for the database. And the default and on-update arguments just mean when you create a new record in the database, it runs the default argument. It can be a Python callable, or it can just be a default value. It should match the type you gave it. And when you update a row, it will call the onUpdate method. OnUpdate attributes value, actually. So SQLAlchemy supports integers, big integers, strings, and Unicode. Unicode text are all of these are Python classes, and they are wrapping standard SQL types. And it also has types like char, varchar, and bool, but these classes above are wrappers on them. So what if you want to do an insert operation on a table? So all these select, insert, update, and delete functions are called on the table that you have created. And the values method receives a keyword argument. Whatever you gave will be used in an insert into statement. They all should be valid or existing in the table, or it will raise an exception. All the statements are, as I have said, going through a connection, and you can retrieve a connection with engine.connect. We have created an engine with create engine, and when you want to run a query, you have to call it on the connection. So a select statement is select statement takes one argument, but it's an array. It could be anything. You can just give the table object that you created, or specific columns. In the second example, we want SQLAlchemy to generate select code and name from countries table. That's what we all want. In the third example, we want SQLAlchemy to generate an as expression, like select code SC from countries table. And from now on, countries table will be called as CT. Don't get confused. And in the first query, all we want is the list of countries that of which region is Europe and Central Asia. And in the second statement, we are asking SQLAlchemy to generate a query that to list the countries of which region is like Europe or Asia. This is called SQL expression language, which is a powerful tool of SQLAlchemy, and you can understand what I meant by function-based query generation. So you write Python, and it generates SQL. So what if we wanted to group the regions with the number of countries and order them in a descending order? We simply use select, and I will get to the func later. It's a separate thing. And we want SQLAlchemy to label the count object as count and group by the region and order by the count that it's generated. And the query it will generate is this: select count countries.id as count and countries.region from countries group by and ordered by. If you want to select a little bit fancy. And the update operation is in select and insert and delete is performed on the table. We simply say that we are going to update the countries record, which is of which ID is 1. We're going to set its name as Turkey and code as true. Let's do a little bit complicated update operation. We have an order list, which is an array. This is an imaginary array, by the way. Let's say it has 3 values, 1, 5, and 6. We generate a case list. Is anyone familiar with case one statement in SQL? Okay. So, case one statement is used in the update operations. And it's basically a way to say when the condition is met, use this value for this column. So we are going to update the photo order. Let's say we have a photos table. We are going to update the photo order and we have a 3 item in our order list, and the photo with the ID 1 will be the first, 5 will be the second, and 8 will be the third. So simply, SQLAlchemy has a case method which generates a case one statement. It takes a list. The first one is the statement. You will see that there's a tuple in the list. And the first one is the expression that says the condition is the ID must be photo ID that we have in the list, and the index will be its photo order will be that index. So the SQL that will generate this update photos, set photo order, and then a case statement, which will say when the photo ID be when the photo ID is 1, it will be 1. When the photo ID is 5, it will be 2. When the photo ID is 8, it will be 3. And the delete operation is also performed on the table. We are basically saying here that the countries with the ID 60, 71, 80, 97, we just want to delete them. And that's not an underscore, that's I'm sorry. Okay. That's a dot there, I'm sorry. So, if you notice that the columns have attributes like, I like, in, and they also support statements like equals, greater than, greater, or equals, or less than, such Python statements. And you can use them however you want. So, what if you want to join? A simple join statement is constructed like this. We have a select from class method, which will create the join table. Join statement for us, and we simply join from one table to another one. If you remember the table creation, we had a data table, and it had a foreign key. So SQLAlchemy automatically generates the on statement. So it will say join data on countries.id equals data.countryID. Or you can use the join method. You can give it the table names, and then you can give the conditions yourself. And of course you can filter the data as you wish. You can do anything you want. So func, I've used func before to count the countries. Func is a SQLAlchemy class that generates SQL statements, SQL function statements that you give as an attribute. You will understand better with an example. So SQL has a concat with string function, which takes an argument as how you want to concat the string, what will be the first argument, and the column names. So SQLAlchemy doesn't want to know about concat with string. It doesn't want to support concat with string, but it wants to have you the option. So when you call concat with string on the func object, func class, it will generate the SQL statement as you wish with the given arguments. And it will generate a select concat with string, the parameter, the first parameter, and then the query, and then the other parameters. So if you notice that, it doesn't use the string as you give it, it uses parameter bundle. ORM. SQLAlchemy ORM is built on top of the core, and it heavily uses the SQL expression language. And it supports class declaration, and table definition is in the class that you create. You don't have to map them separately. So for example, this is the country class that we created as a country table before. If you wanted to create the countries table as an ORM, using ORM, this is how we would do it. Base, is anyone using Django here? So this is, base class is simply the models class in Django. It's the main class that all the ORM objects will inherit from. So you give the table name as a table name attribute, the class definition, and you define all the columns in the class itself. And you don't have to give the columns, the first argument is string as the what's the column will be called. It just creates the column based on the attribute itself. The ORM's main object is the session where the ORM establishes all the connections to the database and keeps all the objects, stores all the objects, and it's the entry point for the query class. And query class is built upon the SQL expression language. For example, okay, I put that at the end, but so SQLAlchemy supports master-slave construction, and all these sessions are created with the session maker helper. It returns a function generator, and for example, with the master session and slave session, we provide an engine as a bind argument, and it returns us an object that we can call, that we can instantiate the class. So let's say we use session maker for master session and slave session. We will have a session and slave session objects, which we can start with calling master session and slave session objects. It's that easy, actually. So when you want to create an object, you can use the master session And when you want to just query, you can use the slave session. Like this. For example, in the first query, we want to list all the countries of which names start with Turk. Or we can just find the count of all the countries in the table. SQLAlchemy also supports a dot count method, has a count method. You can just say session.query and give it a country argument and then dot count. And the joins are simpler. In the third example, we just want to retrieve the country's name and the data related to that country, and we're just going to join the data table. And if you remember, the data table was having foreign keys to countries table. And SQLAlchemy just knows the relation between them and generates the on statement. You could also provide the condition yourself. So, if you wanted to update, we only provide a dictionary with the existing column names of the table. In the first example, we are going to update the row with the ID 1 and change its name to USA. And in the second example, we are going to find all the countries in Europe and Central Asia, of which region is Europe and Central Asia. And we are going to delete them. But the tilde there negates the condition, so this just deletes all the countries which are not in Europe and Central Asia. So, we got that quick, by the way. What if you wanted to create relationships? SQLAlchemy has a magic method, magic class method actually, called relationship. And you can define relationship between tables, between objects, using the relationship object. In the first example, we define a parent ID and have the child class a parent, a relationship to parent. And in the parent object, we say you have children, and you are going to use the relationship with the child object. So two things you have to pay attention. The first one is the foreign key. It has to be a foreign key. And the second one is the relationship class. So if you want to have one-to-one relationship, like Django users know that we couldn't have our own user model. So if we want to keep additional data on the user, we have to create another class called user profile or profile, and something like that. And to do this, we still use the relationship class, but it has an argument useList, which basically says this is not going to be a list of child objects. It will be one child and one child only. And the child object will be able to access the parent with the attribute that is given with the backref argument. When you call it something else, and when you have a child object, and when you want to reach the parent, you will say child dot whatever you gave. Too many relationships are a little bit complicated than Django. Django is a lot more easy. And so there are two ways of accomplishing this. One is using a table object, and one is using an ORM class. So let's say we have a parent and a child, objects which are going to be related through association table. Association table holds the data as foreign key. Left ID is the parent ID, and right ID is the child ID, and all they are foreign keys. So when we define relationship in the parent, we say this parent has a relationship to child using this association table. And then when we give it a backgraph, we don't have to give it a backgraph, by the way. We can just use child.parent or parent.children. The other way is to use the ORM way, and you can give the class a name and define your attributes. And you will have to define your relationship in the parent, and it will use the association class, and it will use the information that you provided as attributes. For example, also, when the parent wanted to reach the child, it will use the association table. So, what are the relationship loading techniques in SQLAlchemy? SQLAlchemy supports lazy load, joint load, and subquery load of relationships. You can say that in the query, you can say that lazy load or joint load or subquery load this relationship of this object that I have, or you can define the relationship in the class itself. And in this parent class, we have a children attribute, which is related to child. And whenever we query a parent object using expression language, it will load the related objects with a subquery. You can do it lazy or joint as well. SQLAlchemy supports events, validation, and many more. It has many more features, and I recommend checking it out at SQLAlchemy.org. Its source is at GitHub, and it has an amazing community on IRC. You can go there and just ask, and people will help you. And that's all. Thank you.